color temperature. However, bear with me, this is actually a super interesting topic showing how temperature is closely tied to the light color. This is a color temperature chart mapping all the various colors we perceive based on the warmth of the rays coming into our eye. So, it goes from the very saturated red colors to oranges, yellows, finally whites, and then it transitions into the other side of the spectrum, going from purples to blues. Oh yes, you're reading this right, the purple and blue light rays are actually hotter than the colors we generally associate with warmth. Warm white, cool white, candle light, extra warm white, daylight, overcast sky, blue sky. This makes a lot more sense, however, when you remember physics lessons and realize that the blue type of fire, the one that results out of adding a lot of air into it, is actually a lot hotter than its red counterpart. To be absolutely correct, properties of light are not exactly the same as that of flame, because there, what type of material is burning also factors in, and there are differences, like the one that flames actually turn from red to orange, then to blue, and finally to white. I definitely don't want to mix up your heads with this. The artistic way. In art, we still talk about blues and violet spectrums of colors as the cooler ones, and red to yellow spectrum as the warmer. In this field, psychology definitely wins over physics, so that's how we are going to perceive these colors as well. The really important stuff here, especially for those of you who want to know how to paint as well, is to realize the progression of colors that this chart offers. In real world, the types of lighting we generally observe, be it the blue or red types, go from these very dark values full of color, to the very bright and even white, almost devoid of color. The brighter the flame, the higher the value of that particular spot. It also introduces saturation, the concentration of color in any given spot. We will not be going with that color temperature spectrum, rather, we'll use this artistic color chart. This is a great one, by the way, because it also shows how colors are mixed together. From these, very efficiently others can be created. And above that, we have various hues of that color seamlessly blending into each other. And then it can, of course, go on. So, for example, green with a little bit of blue and yellow gives you emerald. Now, this is, of course, a bit different from what we know from 3D graphics, where the RGB, red, green, and blue colors are considered the primary ones. That color scheme is not based on mixing colors, rather, it is based on how our eye perceives light through those little cones in it, which primarily perceive red, green, and blue light. Rod and cone cells. In the next lesson, we'll go over the basic terminology connected to this topic.